And that will be able to answer all of your questions along this webinar. So please take it from here, Scott.
Alrighty, thank you, Ben. Again, thank you for attending our presentation for energy storage and electric vehicles. This is our second webinar, and we're going to be doing quite a few others after this. The first one we did was on policy and the updated draft, and there's even some more stuff that came out just recently in the last couple of days about the policies and the bill that's trying to get through Congress. But let's talk a little bit about who we are and introduce our company to everybody. If you don't know, Costa Rica Solar Solutions, we've been actually in business since 2005. There's not very many other companies that are as old as us. I think there's only about 2 or 3 that are left that are from the very beginning. So it's really been an interesting marketplace in the last couple of years since the new policies came through. It's really bloomed. But we have, again, been in business since 2005. We were the very first company to actually permit through the old ESA, what they call Piloto program. It was a 1-for-1 kilowatt hour with no tariffs, and that was back in 2006. Back then, Costa Rica didn't know what was going to hit them. In fact, most people just kind of took it as, well, it's just a solar system. They didn't really understand how much it would actually affect Costa Rica for the future. We were the first company to actually install the Solar Edge system. And what that is an inverter company. Now it's one of the largest in the world. If you look at their stock market, I mean, they're way out there. They're like $230 a share now, where when they first opened up, it was like $21 a share. And so, but we have installed many other different types of systems, everything from N-phase to SMA to all different types. But we kind of use Solar Edge as our flagship because of many reasons. But we're the first company to install them. We also became the first company to install LG Resu in Latin America. Because of a relationship with Solar Edge, it was really a perfect fit with LG because most of our clients were asking for solutions such as the Tesla Powerwall. But here in Costa Rica, Tesla was not willing to come down or warranty or anything. They wouldn't even think about Costa Rica. And so we reached out to LG and found a solution for the majority of our clients. Currently, we have over 250 systems installed in Costa Rica. And, you know, again, it's been really interesting to see the different types of systems and how things have evolved to today's technology, which is it's getting better and better every day that goes by. We do have over 80 LG Resu batteries in Costa Rica, which is really stunning when you look at the North American market. You go to places like Florida, where I'm from originally, Minnesota, and energy storage is really not that popular because the grids are stable. And again, the prices for energy is far less than what we have here in Costa Rica. So that's a little bit about our company, who we are and what we do. And I have to apologize, it probably lags a little bit in these webinars, the pictures and everything else as we scroll through. So this is what we do. You can see this is actually a home here in Escazú. He has 2 batteries, 2 LG batteries. You know, they don't look anything like a battery nowadays. If you look at this picture in the very bottom, that's the old technology. That's the old lead acid batteries that are flooded that we use for some off-grids. But that's what we used to install for energy storage, for battery backup, for small amounts of backup. And what's happened now is pretty much everything. That's about 95% of our business is adding energy storage right now. And Ben can actually fill us in. What does this picture resemble?
Thank you, Scott. This is a This is one of the alpha sites that we were just started to conduct about a couple of months ago. Was SolarEdge understood that the necessity of higher peaks of energy storage is on demand for the residential market share. So what we did over here is that we, in conjunction with SolarEdge, we have installed the new equipment that called the energy backup interface. This is the left bottom box that you're seeing over there that allows you already to combine the up to 3 inverters and 6 batteries and a generator. So you can provide estimated of 15 to 18 kilowatt power during power outages, or just to support less, to minimize the import of the grid, and of course to be independent as can be. Those system works in parallel with the grid, and they're in the testing phase that about next week they will be launched firstly in the US officially. So we're just very proud to be a part of those experiments before everything has been actually launched in the markets.
What's great about that is it's going to be actually having a 200 amp service breaker in there, and that's going to take a lot of the hurdles that we currently have with large homes.
Yeah, and if we'll have a little more time later on, we can speak about a new project that's coming up. That those appliances already allows basically to have rather a partial breaker box or partial loads that you would like to back up in your house or offices or commercials. But more than that, it can already have a full home backup, and we're working with like small homes all the way to mansions to fit their needs, and it's incredible that we already reach that part in Costa Rica today. Not sometimes, not one day. It's already installed in country.
Let's show you a picture of actually commercial systems. Now, a lot of people are very interested in energy storage for commercial systems because it will actually do peak shaving, helping to reduce that demand charges that we currently have here in Costa Rica that are outrageous. We've seen them 65% of your bill. So this is, believe it or not, a battery system. This is, we went up to a manufacturing plant for NEC up in Massachusetts, and inside here they actually have stacks of batteries, as well as the computer systems and everything else. It even has air conditioning, and they're pretty much bomb-proof in these cases. But this is behind the meter. This is actually a product that can go up to 500 kW that is behind the meter and a solution for many problems here in Costa Rica. What an actual, like on a utility size scale systems, this is a cutaway of what you're seeing. As you can see, these are not batteries that look like car batteries. They're cassettes that are actually battery systems that are made by the manufacturers. And they come in and they basically put up a container like this, and it will do many different functions on utility scale size. So let's do a little housekeeping here before we jump into the energy storage. We're going to be doing this in a two-part sessions. One is the energy storage first, and then the second is the electrical vehicle markets. On the left-hand side of your screen, you should be able to see a Q&A. You can actually ask questions, and you can raise your hand as well. This sway, or this presentation we're going to have, after we get done with it, everyone will be able to get a link to the sway, and it'll be provided by the emails, and you'll also get a video of this as well. You can also go to our presentation on YouTube. Now, when you get this presentation, you'll see that we'll have links in here that you can click and go directly to those sites that we're showing. So let's dive into energy storage here. And we're going to talk about first the industry leaders in energy storage manufacturing. This is the battery manufacturers, the top ones in the world, and where the demand is going. Ben, would you like to tell us what this graph is showing?
you see giga factories are just popping up every year in many different countries, and as demand has raised significantly, mainly for the electric vehicle sector, suddenly the same large manufacturers understood the potential of having the same plants, the same chemistry, the same manufacturers and brand names to just scale it up in different segments, communications, home owners that has solar system, and then goes along the list with it. So traditionally, we saw just a few manufacturers that were leading the industry, and it's kind of surprising that at 2020 we still see kind of the same manufacturers that are just keep upscaling their production, their patents, and so goes the list of being the leaders of the industry. LG Chem is today's and almost ever since the largest manufacturer on the globe, has the most patents and basically implemented in so many things that most people don't even aware that they are, starting from like NASA's spaceship parts and all the way to your very computers or solar systems down home, electric vehicles, and so goes the list. So CATL, BID, and Panasonic are the one that goes behind, and many people hear about Tesla. Tesla significantly have probably the best publicity in the world today in this sector, and they at the end also a part of the equation, mainly on actually how much they push the awareness, which we're very, very happy that they do, in order to get energy storage so common in the day-to-day life of most people in North America. Scott, maybe you can tell a little more about Tesla's actual batteries, where they're getting them from, how they implement them.
Well, it's really interesting. Tesla, again, like you were just stating, they actually got the action going in there. People are like, Tesla, batteries, car. But in reality is Tesla actually has partnerships. So Panasonic was one of their partners. And if you look at what's going on in Nevada, that is actually a partnership between Panasonic and Tesla. But what's really interesting is recently LG has gotten the contract for the European for Tesla. So they're opening up I believe a gigawatt factory over there that's going to be supplying the Tesla batteries, or the LG batteries, to the Tesla cars in the European market. So we're very pleased to have a guest speaker here, and her name is Linh Tran. She is actually the North American Director of Sales. And take it away, Linh. Oh, can you hear us? Hello?
Oh. Hello, Linh. Can you hear us?
Oh, we're having a little technical difficulty here. Hold on.
Until Linh will hear and be able to join, we can tell you that the relationship between SolarEdge and Costa Rica Solar Solutions already has, I sincerely can't remember, I think it's already 7 years of like a real close relationship, and Scott, as the CEO of the company, got to really push, before it made any sense, any financial sense or other sense, to already bring LG into the equation. Scott was pushing like real hard to bring a real reliable technology and brand name to be a part of Costa Rica Solutions, which again, it was kind of a craziness at the time, and didn't make financial sense for many years. But now we're starting to harvest those fruits of a very close relationship and trust that been built between SolarEdge, LG, and our company, Costa Rica Solar Solutions, for the past, I think, 4 or 5 years already. And hopefully we'll be able to present a little more of that, like later on with examples and some lifetime, some good stories of what have we done and how our clients are enjoying that today in Costa Rica. And just checking with Lynn. Are
Hi,
you?
Lynn. Are
Yes,
you there?
can you hear me?
Ah,
Yes,
Now
can
we
you
can
hear
hear
me
you.
now?
Perfect.
All
All
right.
right, I could hear you the whole time. Thank you very much for having me. Sorry about that.
Thank you.
No problem. Thank you. So again, Lynn, please tell us about what is going on in, I guess, the North America or the world market on energy storage with LG.
Wow. Well, Scott, that's a very big question. But thank you very much for having me, first of all. And what's going on with energy storage? Well, from North America standpoint and global markets in respect are about the same. So North America, the size of market potential coming into 2021, and Japan, Australia, and Europe all added together are nearly the same. So
Wow.
North America represents quite a bit of the energy storage business, yes. And we've been learning a lot here over the last few years. It's a new market, it's a new industry, especially for consumers, but also for related parties in the supply chain. We're finding that even lithium knowledge on logistics with FedEx, with truckers, some common knowledge around handling batteries isn't known knowledge yet. So that's quickly becoming, we're getting over that learning curve, and it's been very meaningful in the industry to help grow it. And LG Chem being a leading lithium supplier, we are sort of setting the stage for ourselves and our competition for how energy storage is going to be adopted safely and efficiently for all of us consumers,
Wow,
particularly in the home battery market. Yeah.
How about like what's going on in California and in that area, especially with the fires and stuff? Do you see a lot of people? I mean, again, here in Costa Rica, one of the main factors that people are buying, LG Resu or other energy storage is for the battery backup purpose. So how is it happening in like places like California where they have the devastating fires?
Yes. So recent fires and natural disasters in other parts of the country, but specifically here in California, the wildfires have definitely caused quite a bit of demand. California was already the leading home battery state in North America as far as home battery adoption, but we're plagued by wildfires. So having power outages is becoming commonplace. And mind you, in California, years and years ago, we all remember having maybe one outage, maybe two for the entire year, and now we're like looking at the entire week of being without power. So it's a completely different energy landscape in California, and the market is responding as such, and that's why we're seeing the demand for batteries come up. It's great to see the ability and security that a home battery can provide a family when there is a missing commodity that you need for your life, which is power. I think of energy the same way as I think of water. One, because they behave the same way, they flow the same way, but two, we store it the same way as we would an emergency water supply tank. So in natural disasters or wildfires, water is important. So when it comes around with our lithium batteries and being able to sustain a family during outages and during emergencies and bring a big component of relief to an unknown, unexpected, bad situation, it's really good. It's you're selling a good product, a product that is definitely part of a solution in getting not just energy independence, but the way of life that we all maybe used to know and want again. But again, in California, it's a different energy landscape.
Well, it's really interesting because we find a lot of similarities between the Costa Rica marketplace and especially California and Hawaii. The cost of energy here is incredible. We are in that same price category as the Californians and the Hawaiians. Are you seeing issues with probably time of use and those kind of things? How does that affect the battery market as well?
It affects it. I mean, very clearly, if you can save money on your energy bill, not many people are going to say no to that. And there's also you're going to have to get energy some way, somehow. Might as well do it in the the greenest way possible. That it does have an impact, but by and large, batteries are being purchased for that security, for that peace of mind. And you're not really going to put a price tag or a timeline or anything around what it's going to take for you to provide that security for your family. It's now available to you. We don't have to be subject to being without power to our homes, without our food, without our water in some cases. So it's impactful. But I think by and large, where batteries are still and will continue to be adopted because of backup abilities.
Here in Costa Rica, recently they have this draft policy. And it's really kind of interesting because what's happened is in the draft policy, they have come up with definitions. They've come up with definitions of running parallel to the grid. They've come up with the isolation. They've come up with basically battery backup. They're starting to put the framework there. Are you seeing, like, for instance, in these other states where their policies are trying to catch up with the energy storage? Are they putting barriers or are they encouraging?
I would say overall encouraging. And there are too many incentive programs, too many rebates, too many utilities exploring multiple facets of how battery storage is going to affect their grid, both negatively and positively. So I think for simplistic reasons, we can just look at a lot of the solar industry market leaders, the big players out there, Tesla, Sunrun, Vivint, now One. They are Sunrun was very largely into grid services and using batteries as assets, as behind the meter assets. And there's a lot of policy around that, and a lot of that's very forward. And you have to really know the industry in order to really dial into that. And Sunrun did. And that's sort of their go-to with how storage is going to shape their solar business. So they chase policies. You can just look at the markets that they serve to kind of see and understand where maybe some of that grid service adaptation is coming. Vermont in the Northeast started out quite early with Tesla, who was like a Sunrun, and they deployed a battery program for home batteries there, and they were the first in the nation, and so. When we can look at players like Sunrun and Tesla and what markets that they play in, there you can kind of see where policy has initiated first. And they're pretty widespread. So I think it's, from a very, very 30,000-foot level, very high level, the policy is definitely moving in the right direction. We are in the trajectory that we need to go for mass adoption, yes.
Incredible. So what is the future for the size of the batteries? What is the technology going? I know that we talked about in the past where the footprint of the battery was actually going to start shrinking and the density is going to be increasing. Is that going to be happening in the next couple of quarters here?
Yeah, so battery size, the physical size of them are getting smaller and lighter. But their energy capacity is getting up, is going up, and it's more flexible. So you're going to be able to have a more scalable, more tailored solution for a more wider variety of applications. Not everyone needs such a large battery, just depending on how efficiently you use it. So that's where you're going to see more of LG Chem. You're going to see smaller size batteries, higher energy capabilities, more flexible battery form factors and battery capacity sizes. But I would also just make keep a point out that the inverters that we're compatible with are changing and adopting, and the capabilities of the inverter is the capability of the battery. So, you know, the battery is just the gas tank, and then if the inverter is really driving it, we're just a very reliable gas tank, and it's going in the trajectory that you would want a battery manufacturer to go. And the controls that we are being integrated with are becoming much more dynamic and much more a wide range of applications. So it's a lot of flexibility. Batteries fit in everywhere, and LG Chem knows that very well. So that's why you see our batteries will fit into a lot of different solutions.
So how does the North America market compare to the European or Australian or other marketplaces then?
Well, the anticipated market size, you know, is definitely, as I mentioned earlier, large here in North America. I can say from LG Chem standpoint, you know, North America is now, and Europe, Japan, Australia, they have already been in business for a while, years.
Wow, really?
Maybe not decades. Yeah, they're years ahead of us being North America. So my colleagues have been in business. They've been deployed. They have a lot more different products. We make lots of different types of batteries, right? Lots of different sizes. So they sell a lot more variety of LG Chem batteries, a lot more variety of compatible inverters. And we're very single product here in North America. And we're going to be rolling out with more, but not nearly as much as the other countries, being that they are just further ahead in the home battery market than North America. But I will say we're catching up very quickly.
Wow.
And yes,
that's
we
really
are.
incredible, actually. All right.
Yes.
Well, again, thank you for your time, Lynn. Please stick around. We're going to be diving into the next stuff, which is going to be a little bit more of the technology of the differences of the inverters. We're going to be talking about the AC versus DC connect and everything else here. Again, thank you for your time, Lynn.
Thank you, Scott. Thanks, Ben.
Thank you.
So the differences between Tesla, Sonnen, SolarEdge, and LG and others, and we're going to talk about the AC versus DC connected. You really need to know about this when you're purchasing, a product. Is you got to compare what it's going to do, because a lot of people here in Costa Rica are going to try to sell a lot of different systems. They're bringing in Chinese inverters with Chinese batteries, and they're going to say what it can do and what it can't. And believe it or not, a lot of these people don't know what the difference is between the AC and DC, but it's a big, big difference. So Ben, take it away.
Thank you very much, Scott. So to try and summarize the major differences between AC coupled and DC coupled, let's start from the basics and from the AC coupled. So AC coupled system means, in a very general terms, that you will have an AC source, for example, like the electric grid or a generator, or already a solar production that's been converted from DC to AC, that will be the source that charges the battery. So AC coupled in many ways actually doesn't relate to solar. It will just be over there an inverter and a battery that is more standing for a pure backup solution, like a UPS, or like just during the power outage, just to have such and such amount of energy saved for a power outage. So when we do see AC coupled systems that are combined with solar, we're actually seeing two complete separate systems, right? So there will be, in that case, for instance, in most of the cases, you will see like an AC coupled inverter. So that is the part that is connected with the battery to the electric breaker box. And separately, you will also have an inverter and a solar panel system that will also be connected, but to a different breaker box or in a separate way to the breaker box. So in other words, it's not that you have one inverter that plays between DC and AC that can convert and and plate for both sides. It's a little larger system in its components and complexity. So, for example, you can see over here in the picture on the right hand side, you see like the white cabinet. This is the battery bank. On the left hand side, you see the AC coupled inverter. This is a Schneider, for example. And on the right hand side, you can see the Solar Edge inverter, which is connected with the solar panels. So we're seeing absolutely two separate systems. If we're looking on the diagram, just for example, for such systems. So now let's say that there's a power outage. What will happen is that all of the part in the blue, what you see like from the solar panels, for the power optimizers and the solar edge inverter, what called the DC part of it, will automatically be shut off and disconnected because you cannot produce energy while there's a power outage when you have a separate AC coupled system and DC coupled system working in parallel. And we'll get further reasons for that later on in the presentation. But in other words, only the bottom part that you see on the red, that's the AC coupled system. It will kick in and will provide the AC loads. Maybe we can zoom back, Scott, and we can see that this application is has its pros and cons. The pros is that it's kind of easy to just retrofit. Like let's say you have an old solar system or have no solar system at all, you can just connect an AC coupled system only for backup purposes, and it will be fairly easy. There's no parts of like the solar connections and other retrofits on the roofs and stuff like that. That being said, the AC coupled system has major drawbacks that we'll touch only on a few of them over here. The first part is the efficiency. They're not efficient. Let's put it in a simple way. You have three conversions if there's a solar system in order to get the produced power from the solar system to your home loads through the batteries. So for example, you produce DC from the solar panels converted to AC. That's the first step. And then you have the AC power converted through the second inverter to the battery. And then when you really need those loads from the battery or the energy from the battery, you will now need to convert the DC back again to AC for the home loads. So you have three steps in comparison to the DC coupled system, which we'll touch base in a second, that you only have the connection between the solar panels and the battery as a direct channel. So that is the first, like the efficiency. The second part is a very significant one, is that AC coupled system, look on them just as like a limitless source of energy when you can't replenish them. So it's like if you have a generator and you have like a tank of, I don't know, 20 gallon, when those 20 gallons are done, they're gone, the generator won't work anymore. That's the very same thing with AC coupling. And Scott Benson could explain a little bit more about the DC coupling, that over there we'll see how it's a system that is a little more continuous with its different advantages of running for longer periods of time.
Thanks. So how the DC system is, you have a hybrid inverter. It's a little bit different than just a regular straight grid-tied AC system. Again, what we talked about is those are designed so that when the grid goes down, it doesn't feed into the grid. All the panels and everything are supposed to draw down. And that's where you have to have that separate battery and a separate inverter. With a DC system, you have a hybrid, which basically, if the grid goes down, it will use the inverter and the panels to produce that energy for your loads. Okay. What happens is this hybrid inverter has a switch inside it normally, and it will just automatically disconnect from the grid. So there's no chance that it can backfeed and send into the grid. Here's an example of a DC system. Now this is Pica inverters and a Pica battery system. And what's interesting is this one's down in Golfito. They had issues down there. They called us to come in and to fix the problems that they had. And it's similar to the Solar Edge system, but it's a DC disconnect. They could, if the grid goes down, they could go for days, okay, just as long as those inverters wake up in the morning and feed the grid, or in this case, feed the loads and also increase the energy to go into the battery system. We actually have houses that are, they go out and they test it. We put in a system and they want to see how long will that DC connection go. And we have people that have turned them off for months, and they just don't feed from the grid. It's all coming from their solar system and from the battery. And so it's continuous. And we also have some systems that we've used these for off-grid solutions. These were not meant to be off-grid solutions, but we found out with the LG Resu battery and the Solar Edge, it was incredible. We could actually just start it up with a generator, take the generator away, and now it's been going on for years, this off-grid solution. And they love it because, again, it doesn't look like car batteries. So the DC has a huge advantage over the AC, because if you're looking for that grid security, you're not going to get that with the AC coupled. If stuff happens and your system is out for 5 days, forget it. The AC couple's not going to work. But like any kind of system that you have to live within that ability. So if you have 1 or 2 or 6 batteries, you have to be able to live within that. That means that night, it draws down. In the morning, the solar will kick in and it will actually put the energy back into those batteries. So when we look at the coupling pros, again, it's more efficient. You don't have AC to DC, DC to AC, and it goes back and forth. The hybrid inverters filling up those batteries with DC, and it's more regulated charging, okay? And it can run for days, months, and years. We've already proved it. We can see it. One of the cons, I guess you would say, is if you have a current system, let's say it's an N phase or SMA or something like that, you would actually have to change out the whole system and use a Solar Edge or Generac or whatever would be a DC. So that doesn't make sense. That's why it's better just to go with the AC coupled. The inverters such as N phase and all that, if the grid goes down, those will shut off and you'll have to go through the battery backup with whatever you have as an AC coupled system. So what's really interesting is it's not true that all AC systems can be DC, but it's mostly true that all DC systems can be AC coupled. That means you can take a Solar Edge inverter, a Generac, or whatever, and you can make that into an AC coupled system. You can't do it reverse. You can't take a AC system and change it into a DC system unless you add those additional. So which brands of energy storage companies are AC or DC coupled? Okay. One thing we have to understand is that the Teslas, there's going to be a couple other names that we're going to show you, Sonnen and all these other companies. They're using LG, Panasonic, all different batteries inside those cabinets. Okay, so when you look at the storage, you're looking at what systems that they have, not just necessarily the battery system. So if we look at this, here's again a traditional Solar Edge system with a hybrid and an LG battery there. Here is a company called Simplify, and we're going to show you an example here in just a moment. But basically, they use other products that go inside the cabinet, and basically, it's only an AC coupled system. You can't add any panels to it. Tesla. Tesla's a very interesting situation, but they are an AC coupled. You can't take panels and send it directly to that battery. It's really interesting because if you Google right now, if you Google Tesla Powerwall and you look at the pictures of them all in there, pretty much you'll see a box like this, which is the solar edge inverter in the background, which is really interesting. And then Sonnen. Let's talk a minute about Sonnen. I'm going to give the controls over to Ben. So you can actually see a real live Sonnen that we have here in our office in Uvita.
Can you see me? Can you see my screen, Scott?
I see just a black screen. I don't know if anybody else, but basically I just see a black screen.
Okay. I can't see my screen either. Just a second.
Okay.
I see him.
Oh, you do? Perfect.
Oh, perfect. So let's hope that everyone can see me. Yeah, this is our showroom in Uvita. In the back over here, we have one of the Sonnen's component. This is the Eco 6. We rarely work with Sonnen. We mainly work with LG Chem in solar edge. But what we do see that the different companies that are generating this complexion of the AC coupled solutions, at the very end, this is a combination of different components of other manufacturers that they assemble. So over here, I hope that we can see it well. We can see an output 4 kW AC inverter that will pick up the load up to 6 kilowatt of the peak surge. You can see Sonnen batteries, lithium-ion batteries as well, and then there are different components of the Sonnen company that they basically assemble in order to have it as a complete AC solution. So if we would like, for instance, to use that just as an energy backup, that will be a piece of cake. If we already want to have solar included with it, we will already need to add an additional inverter and the solar panels themselves. So it kind of comes back to, again, to what Scott said before, that we just found that for most people, the hybrid DC coupled inverters are just, they just work better in that respect for the needs of our clients.
Yep. Okay, and let's see here if everybody can see my screen again. Hold on for a second. So that's a little bit about what is the AC and DC coupled systems and the different manufacturers and different types of storage that we have out there. Again, there's a lot of stuff coming in from China, a lot of unknown and unbranded stuff. It's easy just to say, let's go for the cheapest. But what normally happens when you go that route, you're going to find out that it doesn't last very long. You're going to have big issues with that. Some of them, again, some of the names you're going to hear: Generac, Fronia, SolarEdge, Sonnen, Tesla. These are just a small sample that is out there right now. Now, what's really interesting is what we actually learned. Now we've installed them. We have a huge amount of systems that we actually monitor. And what's a little different from our systems versus others is we not only just monitor the system production, but we can actually monitor the total consumption. And we also monitor the import and export and self-consumption. And Ben's going to dive into that in a couple of minutes. But what we found out with our company after installing these products, especially with the LG and the SolarEdge, is we became energy managers. What's actually happened is we were able to find problems and solve them by using the monitoring system that we have. And what we found out is that if you're within that 600 kilowatt hours at night or 600 watt hours at night, you could pretty much go throughout the whole night long just off of the battery. So Ben, take it away. We're going to show you what we found out in this case.
Okay. Well, let's put it this way. So the key benefits and the features that we kind of explored in now we're gonna see some real life examples are, first of all, electric bill savings, or energy savings and electric bill savings. This portion is divided into two parts. The first part.
Can everybody see his screen? Just want to make sure.
Can you see my screen, Scott?
Nope, mine. I've just seen it black. So I was just hoping, Brian or Ariano or somebody, can you see his screen?
I see Ben's face.
Perfect. Now you have to share it. Share your screen.
Entire screen. So sorry, guys. Here we go. Okay, can you see now?
Yeah, I can see it.
Mm-hmm. So what's going on over here is that the part of the benefits with the electric bill savings is divided into two parts. The first part is basically it's arbitrage. It's taking charging electricity during specific times and discharge it in other times. It mainly works for hourly tariffs that has different tariff structure depending on the hours of usage or consumption. The second part of it is to increase the self-consumption. Self-consumption, just to talk about the term, it means that whatever you produced from the solar system, you consume it at the time of production, or that you charge your battery and then use it later on during evening times, for example. So that's the combination of the energy saving portions. And then comes the part that we see that the majority of our clients are actually the most interested in, which is the emergency power backup. That we'll see a few examples of that. It assists in permitting process. We won't jump too deep into it, but we'll talk a little bit. And it allows us to have a microgrid benefits. So what are all of those fancy terms? Let's go and see in real life in graphs. So this is just a regular day, sunny day. There's from 6 a.m. to 5 p.m. solar production. Over here we can see, like in the red over here, it's whatever been imported from the electric company. Those are the loads of the house. Over here it's nighttime loads and nighttime as well. And over here, this term that we said before, the self-consumption, whatever was produced during daytime, some of it was exported and fitted back in the grid. And the other part, the home loads or the loads of the house at those hours of production, was self-consumed by the solar production, or offset by the solar production. So what that has to do with a battery? We have the solar system that charged the battery over here. This is the battery. This is how the LG battery looks in this particular graph. Over here is 100% full. Over here is completely depleted. And that was a battery that had been used during nighttime to save some of import of electricity from the grid. And now during daytime, we have the solar system programmed to charge the batteries as it also provides the home loads. So once the battery is 100%, it just maintain like that. And we program that system to start discharge from 4:30 p.m. in order to minimize the import of electricity from the grid. So by that, we're basically increasing the self-consumption using the solar energy provided. So we don't really need to just send it back, feed back in the grid and receive certain benefits. We're getting better benefits by using that production, charging the battery, and later on discharge during nighttime. Peak shifting. To try and make it simple and nice, that one of the most important part that our guest Linh explained before is the integration parts between the manufacturers. So one of the reasons we chose to work with LG is that SolarEdge and LG have a wonderful cooperation in the BMS, in the battery management system programming. So for each homeowner, we have the access, and we're doing a particular custom energy profile or storage profile design based on your needs. In that case, I will just show you one example of the discharge to minimize import. We program it between 11 p.m. and 8 a.m. each night. So we just like give an example. This is a home in Ojochal, down south in the Pacific coast of Costa Rica, that we decided in conjunction and together with the homeowner that we will start to discharge energy from 11 p.m. and all the way to 8:30 a.m. Why did we do that? Why did we program the battery that way? What we wanted is to have basically a combination between energy savings and also the backup power for the hours that are more critical for the homeowner. So, for example, if one battery in this profile can last for about, let's say, 9 hours. So instead of starting the battery over here at 4 p.m., which we might have additional energy savings, we wanted to enjoy both worlds of energy savings and stability and reliability in case of a power outage. So the idea is that if there is a power outage that starts somewhere in the late afternoon or early evenings, the battery will start fully charged. So then it can cover as many hours possible without when it's still fully charged. And most of the electric outage do not last really 24 hours. They're usually between 2 hours, 3 hours, sometimes you have 5 hours. But the idea is to get as many hours available for the homeowners. So we also program that the clipped energy means energy that's been produced by the solar panels, but exceeding the home loads. So first the solar system provide the home loads, and whatever is exceeded, then it goes to charge the battery. This is what you're seeing over here, that the solar system, not the grid, the solar system that will directly charge the battery DC to DC in order to have it as efficient as possible. No losses of DC-DC conversions. Here comes the second part of the energy savings. So the energy savings has a feature of time of usage. In Costa Rica, it's a fairly new thing. In North America, it's already pre-established in many states and electric companies that you have planned tariffs, right? Like that for whatever consumption you have based on the tiers, you will pay a planned tariff. Over here we see CNFL, it's a government-owned company by ICE, that they also have today the hourly tariff structure for their residential tariffs. So just to give us a simple example, take a look how extreme are the differences between the cost of nighttime cost per each kilowatt hours per each unit of energy versus they call it punta. It's like the peak consumption hours, and we're talking about again extreme numbers of close to 600% of differences. It's extreme in any ways that we receive it. So just to give a simple example, and you can actually have even better benefits than that, but just to give an average of what you can actually save by just using arbitrage of charging the batteries from nighttime tariffs, if you don't have even a solar system. Just charging the battery from the nighttime cost of energy and discharging it at those peak hours, you can roughly have $800, $900 of saving per year. If you're doing the same thing by having solar charged to the batteries, you can even get like to above $1,000. So you still get all of the benefits from the battery of having like a stable energy source when there's a power outage, but actually you do have a return of investment. And that is something that we didn't take in consideration at the beginning, that we just saw it, or mainly saw it as an energy source for power outages. We suddenly understood that the arbitrage just by that could have a return of investment. So to take if you take a generator right now as an example, from the moment you bought a generator, you will always just keep spending more money. You will buy more gas, you will pay for filters and maintenance, and so goes the list of expenses. With this LG battery, you can actually make money or save money. So this is it. This is like to give a little bit our 2 cents of what we've learned in that part of the battery. And I will get it back to you, Scott.
Thanks, Ben. As you can see, we've learned a lot again from these systems, and what we're seeing is again, our expertise that we're putting in here compared to a lot of other marketplaces, and the amount of energy systems that we put in our energy storage systems, we're actually able to help the client to save more money, to be more reliable, and to live more autonomously. Okay. And that's really going to be going into the next segment. But what we really have learned also is to make that house more efficient even before we're actually putting in the battery system. What does that mean? Well, we need to use variable speed pool pumps. Okay, so when you're having a pool out there and everything else, you want to have that on the backup panel. We need to make sure it's variable speed. You start at low RPMs and it goes up to the higher to do that. Next, we need to have inverter AC style systems for your air conditioners, high efficiency appliances, and especially for the ACs, we need a SEER 19 or above for an AC. Most of our clients have learned the hard way that here in Costa Rica, when they are asking their subcontractors or contractors to put the AC systems in for new houses, sometimes they go a little cheap, quite a bit cheap actually, and they'll get you the lower SEER rating ACs and they'll install it, and then they're asking us, well, why is our bill so high? And we've come across this in new construction, and one of our clients, because we were able to see the kind of energy that they were losing, they went back to their contracts and found out that the electricians put in a SEER 13 instead of SEER 19 or above. And we're talking about a 30 to 40% savings just by changing out the air conditioners. They had to change 10 air conditioners out. Again, all these will have links. You can actually go to them, and we actually have blogs and information about that. But it's highly important to get your house set up so that when you do put in the energy system, the energy storage, at night you're using lower energy and you can get more out of that battery. We also found out that you can run totally parallel. We have a lot of houses that normally use 1,200 kilowatt hours a month, and they're about 98% between the solar and the energy storage. So that's huge, because with today's policies that are trying to go through, if you're running parallel, you don't need a permit. Now, all of a sudden, we don't need to go through ESA to get a permit. And in the United States, they could call that grid defection. The next thing that we found out is using smart home devices such as Google, Alexa, and others that will actually shut off systems while your battery starts depleting. We have a client in Escazú. I mean, he's really a tech guy, and he was able to set it up so that when the battery gets down to 75%, it will start shutting off things in his house. Okay, so it will get to that point where it just starts shutting things off, so he gets more time on his batteries. So let's open it up for questions. I know we have a lot of questions probably for Lynn and for the group. If you look on the left-hand side, you can actually raise your hand, or you can actually type in questions here on the side. Does our panel have any questions, I guess, for Lynn?
Well, I will always be very happy to hear a little bit about the new models, if are already could be shared with us, of the residential size batteries and the different advances that has been changed for the newer versions. As we know that there were different changes from the series number 2 or the version number 2 of the LG Resu 10 battery. And again, I'm just interested to know if there are certain capacities that are going to be changing over there. If suddenly the battery will be 20 or 30 kilowatt hours of power for single phase, or if the chemistry is about to change in different things like that.
Oh, let's open up. I think we got Lynn. Lynn's audio is not connected at the moment. Well, let's answer some. There's a couple of questions coming in. Let's see here. I guess Bill Bennett has, I am concerned about the life expectancy of batteries in the tropics. Home sweet home is at least 10 degrees. It's really kind of interesting because I actually have a electric car, Chevrolet Volt, and it actually uses the LG Chem batteries in it. And what we found is that in this kind of climate, there's no degradation. We haven't seen any degradation issues, especially with the General Motors. If you go and Google it, the LG Chem batteries for the Chevrolet Volt, they didn't have any degradation issues, and they never sent them back for that. One of the things that we have to do when we're dealing with these batteries is to make sure that it has airflow around the battery system. So when we put it on a wall, we need to make sure it has so much distance around it so it gets that airflow in it. I've been out to some of our systems, which we actually have one that's up in Tamarindo that's inside a pool house, believe it or not, and because that's where the main breaker box was. And in the shade, the highest that it gets is roughly around 80 degrees. And these batteries can go up to 125 degrees maximum without starting to create degradation issues or whatever. But I guess Lynn, I don't know if Lynn, if you can maybe change your connection there. We also have another person that's putting their hand up. Let's see here. I think we had a couple in there. When charging an LG battery, what is the maximum amount of kilowatt hours that can come from the solar panels to charge it? That's what Paul's saying quickly. So Ben?
It will be.
Oh, go ahead.
Up per today with the current charging technologies, we're talking about 5,000 watts that could be charged or discharged through the battery with the combination of storage and LG Chem the Resu 10 batteries. And that's in order to keep it to not degrade or to not damage the technology. And that's per a single battery. But that being said, Paul, what we do see is that now there are new products that are being launched with the same batteries, but with different inverters that allows you to connect with this energy hub up to 3 inverters and up to 6 batteries. So they could be charged or discharged in 15 kilowatts or 15,000 watts at a single moment, rather charging or discharging. And they can supply actually a little more loads to the home, but this is a different story. Second.
Let's see here. I think the next one is, and this is from Daryl. I am building a house right now and already have the pool equipment and air conditioners installed. Will I have to change out this equipment prior to having a solar system installed? I don't plan on living in the house for maybe another year. Right now, my electric consumption is for the pool pump. Again, it just depends on what kind of system that you have for your pool pump. We have to first find out, does it have variable speed? If not, we wouldn't be able to put it on the backup panel. You still use the solar system and everything else, but what happens is when the grid goes down, it won't be able to back it up because of the high peaks that once that motor comes on. Again, what we need to do is look at your equipment. What I would suggest for everybody is to go back and look at their air conditioners, because again, a lot of people don't really see this, but go back and look at your air conditioners and your pool pumps and actually see if it does match the variable speeds, and especially the SEER ratings. I mean, if you go to EPA, for instance, here in Costa Rica, you'll see them selling SEER 14 and 15 air conditioners. And it's a couple $100 less, but boy, you're spending a lot more money in your monthly electric bills. Let's see here. Is there anything else?
If there will be more questions, guys, please feel just comfortable to just keep writing them, and we'll answer as it goes in the flow of the presentation or at the very end of it. So,
Yep.
Yeah, I think it's time to go to the chapter number 2.